I would like to show you how this value, which is an integer, is passed as an input parameter to function square. Recall that we discussed earlier that when main is invoked by the operating system, its opening brace constructs a stack frame, otherwise known as placeholder for local variables, to accommodate all variables created by this function. In our case, we have value and result, two local variables that belong to function main. So when the stack frame is allocated, it will have spaces for the two of these variables. For instance, if this place is reserved for the value variable right here, then you can see that we are using this to specify it as an actual parameter before we call function square. When C++ compiler generates code that implements our function call, what it does, it copies this value to a memory outside of the stack frame that belongs to function main. Right? So it basically makes this copy. So if this was 5 initialized, an integer that was initialized to 5, the value is copied to a memory just outside of this stack frame. Then compiler generates the code that transfers control, as we demonstrate right here, to function square. So we jump from here to execute function square. Function square, before it starts its execution, understands that it has an input parameter, integer value, which is also treated like a local variable. So its opening brace constructs a stack frame which will allocate space for the parameter of this function. In other words, the square, before it does anything, it constructs a stack frame, its own stack frame right here, right next to the space that's available after the main stack frame. And it just happens so that when the function begins to execute, the placement of variable x coincides with this place where we already copied this variable outside of the local scope of main function, and this is how this is like a trick that makes this variable x the input parameter of the square function to get initialized with whatever the caller was provided as an actual parameter. So this is how it gets its value. You can see that this is by copying. So we copy the original value and we place it in the scope, which will eventually become the scope of local variables of function square. So then this function uses this value to make its computation and returns its value as an integer. The process of returning the value does not involve stack frames or using local scope variables. The return value right here, which is computed, is returned by the CPU itself. So if we have our CPU, central processing unit, that executes our program, it has its own internal memory, and in the process of returning this value back and transferring control back to continue execution of function main, the CPU internally preserves the result of this function and then copies it over to the result right here. Or I could show it that the result is copied right here. So this will be 25 and of course we already know that this is the value that was computed by the square, and so this is how the return mechanism from function works. So the input parameters are copied over outside of the scope of the current stack frame, or a local scope of our current function, and input parameters assume places where these copies are made, and so this is how our x gets its initial value. But on the way back, this mechanism is not used. Instead, the value is transferred directly through a temporary memory, or one of the CPU registers, to pass the value back to the caller. And so this way we accept the result from this function call.